Okay, this is the pendulum. In the simulation, we set this length to be 0. And this is the trajectory of the pendulum. So let's say that you let it go from this angle theta over here, and you want to know what is the height from here. So this is the reference point. So you set this to be h0 meters. That means the potential energy is 0 right there, and you want to know what is this height. You want to know what is the height. Given the length L, and this is L obviously, and the angle. Okay, so the first thing you do, you draw this line over here, and you have this triangle. And because this is also h, this over here is L minus h, and L minus h is adjacent to the angle, so cosine of the angle is adjacent over the hypotenuse. So you multiply by L and you solve for h. So h is this negative, so it goes to this side positive. This is positive, so it goes to the other side negative. Take L common factor. So h is L. If L is 1 meter, then h is 1 minus cosine of the angle. So this is the equation for the height in the pendulum, because it's easier to measure the angle. You could put a ruler, the meter stick over here on the table to measure the height, but that's or in the simulation. But it's easier, it's always easier to measure the angle.